Okay, so before we start the sorry, the exercise on NLP, let me spend few minutes and brief you or refresh you, what actually we will be doing here. Right, this is the review sentiment. This is one of there are few other use cases as well in NLP, like for example, text classification is one. This is what actually we are doing. All right, then sentiment extraction and topic modeling, entity name recognition. Okay, so named entity recognition in ER or entity name. Okay, so this one is key, all right, because sentiment and topic modeling these days, I think GenAI is more powerful than NLP, right? So named entity also, I think GenAI is more powerful, but these are kind of older, apologies, older version, older algorithms. If you're interested, just get a brief of what exactly this one. But this is very important, text classification, because when you get millions of reviews, it is not possible to classify them whether it is a positive or negative. Why this is important is if your customer is not happy, then immediately you can take the action, right? So so far, previous examples, we worked with numbers, images, and we have seen LSTM as well. Now, the language part. So in e-commerce, customer write reviews. Just now I briefed, right? So product quality is good, but delivery was very late. For example, customer says that product quality is good, but delivery. This is usually, I mean, you can easily connect with your experience, right? So you suppose if you're not happy with any service or product, if you purchase or event, if it's a service, right? So you always tend to give the reviews. So delivery was very late. So what is thing here? The quality is good, product is good, but delivery is late. For a human, this is easy to understand. We immediately know the customer is partly happy and partly unhappy. But for a machine, this is just a text, right? So NLP, natural language processing, helps machines convert human language into something they can understand, right? So the first step is we discussed in theory class also, right? Cleaning text. So we remove unnecessary noise like extra spaces, symbols, sometimes common words. The second step is basically convert these words into numbers, right? So machine learning models cannot directly understand English words, right? So we have to convert the text into numeric form. There are simple methods. One simple method is term frequency, inverse document frequency. Term frequency. The second one is inverse document frequency, IDF. This is actually one method only, TF-IDF, but two different approaches. So if a word appears often in a sentence or in one review, but not commonly across all the reviews, it may be important, right? For example, there is a refund, the word called refund, or like let's say there is a broken, right? Or there is a damaged, right? So these can carry strong meaning, right? So this sort of thing you have to do. The third part is basically trying a classification model. So what is this classification? We went through the theory, the math intuition, and we have seen an example, and we discussed the output also, like classification output, like metrics, accuracy, precision, recall, everything. Only thing is earlier you had numbers, wherein here the text, and there is a target feature saying that it's a positive or negative, positive or negative. Simple. So or neutral also sometimes, right? If it is neutral, it is neutral. So this is similar to churn classification, but instead of customer profile columns, we are using the review text as input. The business value is very clear here. Instead of manually reading, let's say 50,000 reviews, right? ShopSpear can automatically identify which customers are unhappy, right? Which issues are increasing, right? And which products have quality problem, and which days a particular customer or which region more refunds are occurring, right? which reviews needs urgent attention. So these sort of key business, analysis or insights can be extracted from this sort of approaches. Okay, so let's discuss the text classification. We have data. Uh, so the data is basically reviews. All right. So this is the data. So this is a review ID. So review also an ID is assigned, order ID, for which order the customer has given the order, the review. This is the customer ID, product ID, which respective, and then this is the review date. What is the respective rating? And then review text. If you want to read value for money, I'm happy with this product and would buy again. This is a positive. If I look at a negative example, this one, right? The product had damaged packaging, right? Please improve this experience. So rating is 2 and the negative experience. The category is basically package. So who actually assigned this positive negative? This is not NLP. This is human. So based on the past data, human actually have given, some rules. Suppose if it contains something like that, they have given already classified the review as a positive or negative, right? So based on this data, now you pass this to your what you call text classification. Give customer ID or review ID 1, 2, 3, 4, and then simply your target variable. So machine will understand for what sort of words, right, based on the TF-IDF logic, is positive versus is negative. So then it will create a model just like a y equal to a plus bx in a simple layman language, probability of y equal to positive or negative. Then tomorrow, if any review comes in, it has to pass through this output. I mean, sorry, the pickle file, the model output, the scored equation. This scores actually the probability for being positive. Suppose if you are building the model for positive. So greater than 0.5, it is 1, else 0. Right? Same logic, same fine tuning. Right? So here you don't need to go with XGBoost and all. I think logistic regression. Okay. Navy base is one more algorithm. There is, I'll discuss it in a while. Right? So you can use any sort of those algorithms to classify text. This is actually text classification. As I discussed, you can do sentiment extraction, you can do named entity recognition, you can do topic modeling as well in NLP. These are the 3 other approaches, or I could say applications of NLP, but GenA is dominating than NLP for these 3 use cases. So we'll discuss one more in GenA. Right? Now let's see the code and discuss the output and how to read the output. Okay. So this is the Python code. So NLP sentiment classification for customer review. All right. So the business goal is to classify the customer reviews as positive, neutral, or negative. So 3 classes basically here. Earlier in the churn prediction example, you have whether the customer will churn or not. 2 classes. So that's a bi class or bi-modal. This is a multi-modal. Okay, or multi-nomial classification, multi-class classification. Okay, that is binomial classification. So now, as usual, you have to bring all the required uh, what we call libraries, the respective libraries for text pre-processing, TF-ID, term frequency, inverse document frequency vectorizer. Vectorizer means it actually count the words and transform that word into a vector form, a number form, so the machine can understand. So this is a negative binomial. Navy bias, I'm sorry. Navy bias is one other model, right? Logistic regression is another model. So these are the Navy bias, SVM. These are also 2 other classification algorithms, but in reality, XGBoost you can focus on more because that is the most relevant algorithm for heavy data in real industries, right? So bring the data, load the data. So please change the directory. So where you actually stored these data sets. Then once you load all the reviews, right? So you have to, if you want, you can actually print and see, index the text and review so whatever labels you have, sorry, review positive, negative, give the label, sentiment labels, right? So after the preparation of the data, prepare modeling data frame, right? So if there is any column, right? So for example, if you don't want any observation which is having a different text or some unusual, you can do the cleaning part. The basic cleaning part, this is the cleaning of the text. What this is a simple formula in Python where you're actually seeing some unusual or some special characters to exist, remove them. Or some, apart from your A to Z, small letter or capital letter, or some number 0 to 9, anything else is there, remove that. Right? So that is kind of a cleaning. Then you divide the data into train and test. So this is the baseline NLP wherein you are actually using the TF-IDF vectorizer. So for your text, each and every column, the text in the text column, review column, right? Similarly, logistic regression. So logistic regression, what are the key parameters? So it is actually using the logistic regression algorithm here. So then Navy Bayes is another algorithm. It is basically depending on the Bayes theorem. Bayes theorem is nothing but your present, probability for present event is depending on your prior. So prior probabilities and present is considered to predict the post coming event. So it's a simple logic, in my algorithms class, you will see all these in detail. So then once you have the data, you run the algorithms, then compare the accuracy. So fine tune, whatever is, this is max features, n param range, C coefficient. These are the few hyperparameters. You can compare different scoring mechanisms. You can see these in documents. That's fine. So my suggestion is only focus on these hyperparameters, and there are different scoring algorithms available. You can change and see if you are improving accuracy. Right, so the best output you're getting here and you're printing the same thing, then yeah, you're actually, if you want to see the sample prediction for a few reviews, you can also see the inner output, right? If you want to store as a database, you can actually store and score that model and use it for future reviews, right? So that's it. So let me go to the output here. So this is my data. So this is the review and this is sentiment positive or negative. All right, and then so you have see, this is a simple example, cleaned text, right? Value for money. I'm happy with this product and would buy again. So there is a full stop here. So there is a dot here. There's a full stop. So the expression that we have written, right? It is removing those special characters, right? Then it ran the models like classification, logistic regression model, accuracy 70%, and precision and recall. For negative, it is 0.61. For neutral classification, 0.26, and positive, it is 1. It is predicting really well for positive, but yeah, for others, it is not really. This is the confusion matrix. Now you see here, accuracy for from Navy Bayes is 78%. From logistic regression, it is 70. So technically, Navy Bayes is helping to get more accuracy, but check the recall and precision values. If you see here, neutral 0.26, but here it is 0. So I prefer to go with logistic regression. Right? That's it. Similarly, the classification report and some sample predictions here. If you see, if you want to validate the model is accurately predicting or not, the product quality is excellent and delivery was predicted sentiment. Sorry, the delivery was fast. It's a positive sentiment. The item arrived late and packaging was damaged. It's negative. Product is okay, but delivery took longer than expected. This is neutral because he didn't show any frustration that, it is late, I'm not happy, something like that. Right? But worst experience, I want a refund immediately. It's a negative sentiment. Good value for money and very comfortable to use. Positive sentiment. Right? Similarly, you can try scoring, randomly picking data from your training data sets or your master data set and see if it is helping to. So there's a simple interpretation. See the reviews and identify the customers who are repeatedly giving negative reviews. Try to do some strategy over there to control the churn. You can relate NLP sentiment classification and your churn prediction both. Use outputs of both the models and do more strategic way of controlling the churn and improve the customer service experience. This is the use case. So to conclude, NLP sentiment classification is a method wherein if you have already classified reviews, you train the model using TF-IDF, then the text gets converted into the vectors. That vector can be leveraged through a logistic regression or any other decision tree, any algorithm classification run similar exercise what we did for churn classification. Then use that equation to predict the sentiment for future reviews. Okay, so this is NLP use case. So the code is available in the same folder, so you can download and run, and you see in practice. I hope you understand at high level what is NLP, when to use NLP sentiment classification, right? Let's move to the next topic.